and share my screen. So today is probably the last class of functions and coordinate plane. Been working on it the past 2 lessons. Been going over slope, x-intercept, y-intercept. That's what we did last time. We did the distance formula and the midpoint formula. Today we will be building up on that and finally be able to write the equations of lines. So just a reminder, we will not be having class next week because it is spring break. We will resume class on April 7th. Okay, so on April 7th, we will resume class. All right, let's begin. Functions in coordinate plane, lesson 3. First, we'll go over homework questions. We will review the slope. We'll go over some graphing forms and then have some practice problems. So let's first do the homework question. So I'm going to give you a couple minutes to do this and then we'll check it. Right now. Let me just, yeah, okay. Anyways. Okay, let's go through this one. So we have a couple answers here. X-intercept is equal to negative 10.6. Y is 5.88. Okay, and Ivan says negative 53 over 5, and Y is 53 over 9. I mean, I haven't done the fractions yet, but they seem pretty similar. Probably are the same answers, so that's good. Let's look at this. So to find the x and y intercept, you need to really focus on the definition of what the intercept really is. So the x-intercept here, for the x-intercept to exist, the y-coordinate needs to be 0 because it touches the x-axis. Okay, so to find the x-axis, we just need to set y is equal to 0. We set y equal to 0, this just goes away. We have negative 6 is equal to 5 thirds x plus 7. Okay, we're gonna get negative 6. Okay, let's just go to another line. Hold up. Negative 6 is equal to 5 thirds x plus 35 over 3. Okay, and negative 6 is negative 18 over 3. Negative 18 over 3. So we have what's negative 53 over 3. Okay. Go to 5 thirds x. And then you can just flip it. Flip the fraction. It's going to be now x is equal to negative 53 over 5. You could have done it any other way. You could have, did this first. A lot of different things you could have done, but you should have gotten negative 53 over 5. Okay, so for the y-intercept, it is basically the opposite. You need to set x is equal to 0. So y-intercept 3y minus 6 is equal to 5 thirds 0 plus 7. So that's just 7. 3y minus 6 is equal to 35 over 3. 3y is equal to 53 over 3. Y is equal to 53 over 6. Is that correct or not? Let me see. Okay, so Ivan, you got 3 over 9. So I did something incorrect, right? Okay, no, yeah. It's not 6, it's 9. Okay, so you should have gotten negative 53 over 5 and 53 over negative 53 over 5 and 53 over 9 for the intercepts. So the concept is quite simple. You need to set one variable to 0 to find the intercept of the other. So that's the key point here. Make sure you know how to find the intercepts. It is important to graphing a line. Okay, so a function includes the points displayed in the table below. Find the slope. So here are the function points. You don't have the actual equation of the function, but you do know what points are included in the function, and that's all you need to know to find the slope. Okay, I'll give you a couple moments to do this. Okay, let's go over this one. Okay, so you should have gotten slope is 4. So this one, you need to remember what the definition of a slope is. Okay, so slope is equal to m. That's the variable that we use. It is delta y over delta x, meaning it is the change in y over the change in x. Let's see what the change in y is. That's the difference between every y value here. So if we look at -2 to 2, what is that? That's a 4, positive 4 jump. Again, a positive 4 jump. Again, positive 4 jump. Okay, so we clearly have a positive difference. That is the change in y. Let's put that on top. Let's see what happens in x. Okay, so we go by 1, went by another 1, by another 1, okay, by 1 again. So here, obviously, the change in x is equal to 1, so we just get 4 as our slope. So that is the change in y for every 1 increase in x. The y increases by 4. That's the rate of change. Okay, so that's the slope. And finally, we have this one. Find the slope of the line parallel with this line y is equal to negative 3x minus 2. Let's do that real quick. Should not be too hard because I did talk about this last time. Okay, let's check these answers. So when you find something parallel, you have to just use the same exact slope. That's it. Because if you want two parallel lines, you see you have two parallel lines. This red line is parallel to the green line. Okay? They will never touch each other. And the only way they will never touch each other is if they increase the same exact way and they decrease the same exact way, or anything. They move the exact same way, or the rate of change is the exact same. So thus, we must have the same exact slope, must be -3. Okay. So now let's review some of the most basic vocabulary that we need to start learning about these graphing lines like this. So I'm just going to go ahead and ask you guys to define these terms since we've already learned them before, so it should not be too hard to define them. So I'm going to give you a couple minutes in chat to just look at your notes again, give me a good definition of what the y-intercept is. Okay. And yeah. Okay, so let's see what you guys said. Okay, so yeah, so basically Yuchen is correct. X-intercept is when the y is equal to 0. Y-intercept is vice versa when the x is equal to 0. Okay, more formal definition is what Braden said. Y-intercept is when the line is intercepting the y-axis. Okay, and the x-coordinate is also 0. Vice versa for the x-intercept, it is when the line touches the x-axis. Or any, it doesn't have to be a line, could be anything, could be a graph of a squiggly line. The x-intercept is when it touches the x-axis. I mean, I think it's pretty straightforward. You can tell from the name, x-intercept, okay? So now let's go on to, we'll just write these definitions down. When the graph touches the x-axis, the y-coordinate is 0. When the graph touches the y-axis, and the x-coordinate is equal to 0. Those are the definitions of the intercepts. To find them, you simply have to set the other coordinate that you're not trying to find to 0, then you'll find the intercept of the desired coordinate. So it should not be too hard for you guys. All right. Let's go on to the slope of a line. Okay, so you really need to know the slope. Okay, you need to know how to find the slope, but you also need to know how to find it quick. You need to look at 2 points and you need to know the slope, right? These things build up. Okay, so let's review slope of a line. Okay, change in y over change in x. Okay, rise over run. Now, whatever you want to remember it as, but usually we go with this. Okay, or x1 minus x2 doesn't really matter as long as we're subtracting points and you're consistent with which point you're subtracting. Okay, it's the same slope. All right, and basically change in y means you take 2 points and you subtract their y coordinates. Change in x, you take 2 points, subtract their x coordinates. Okay, we have a line here. Say we have a line. Okay, so red line here. And okay, 2 points. We have this is the y2 minus the y1. This is the x2 minus the x1. Here we go. And that's how you want to do it. It's just the ratio of these legs of the right triangle, I guess. It is the rate of change here. That is how you find the slope, basically. If you want to know how to interpret it, okay, so for every, let's say, you know, something increase in x, the y increases or decreases by something. Okay, so it depends. So what do the slopes mean? Positive slope means the graph is increasing here. See how this is positive slope because the graph is increasing, you know, it's lower at the left end, it's higher at the right end. It's increasing. Both variables are increasing. X is getting bigger with each point. Y is getting bigger with each point. They're going the same way. That means increasing. Okay, if they're going not the same way, then obviously one of the changes is going to be negative. One of them is going to be positive. We're going to have a negative slope. that means it's decreasing. Okay, so if your x is increasing but your y is going down, that's a decreasing graph. It's going to be higher on the left end and lower on the right end. You're going down, right? You don't want that, especially not on your stocks or anything or anywhere. Okay. So now let's go on to the slope-intercept form. Are there any questions on slope before I begin? If there are no questions, then I'll just start. So slope-intercept form is y is equal to mx plus b. I don't know if you've heard this before. It is pretty standard. Okay. So you want to draw a line, right? So what do you need to draw lines? So can everybody just brainstorm in the chat what we need to draw a line? Any questions or any answers? We need to draw a line. What do we need to draw a line? Is the most simple line. I don't care about any details. To draw a straight line, what do you need? You type in the chat. Okay, that's correct. So Yushin is correct. Any 2 points. So can you draw a line from 1 point? You can't, right? You can't draw a line that you can control in 1 point. You don't know where it's gonna go. You don't know how big the slope is, how steep the line is with just 1 point. It can rotate, it can do whatever. You don't want that. Okay. Instead, you want to have 2 points. All you need is 2 points. And as you can see from the next 3 methods, we are getting these 2 points in many different ways. Okay, we're getting them in many different ways. It doesn't matter which 2 points, we just need to get 2 points, and then we can draw our line. So each of these methods that I'm about to show you have their ups and downs. I'm going to show you one of the best forms. It's probably the optimal form to write a line in. So this is probably the most popular slope-intercept form. So most schools start with teaching this, but actually I'm going to tell you that the point-slope form is much more useful. But we're going to start with the slope-intercept form first. So the slope-intercept form, I'm going to tell you what each of these variables mean. The y is just, y coordinate. It is the output. That's fine. Okay, and x is the input. Okay, we already know that. So now we're going to talk about what b is. B is actually going to be your y-intercept. Okay, so b is going to be your y-intercept. And then let's say m is obviously your slope. Okay. So now let's practice on how to use this form to write a line. Okay. So let's say we are given y-intercept is 4, okay, and the slope is let's say 2/3. Okay, so I'm gonna have you guys write the equation of the line real quick and then put it in chat. Okay, so write the equation of the line real quick and then put it in chat. And then you can also graph it. Okay, so let's see your equations. So basically, that's correct. Okay, so you're given the slope, you have the y-intercept. That's good. Y is equal to what? 2/3 x plus 4. Okay, that is our equation. So now it's very simple. Just plugging in the numbers. It's not that hard. Now we can actually start trying to graph this. Okay. So if we try to graph this, where do we need to start at? The equation gives us the slope and the y-intercept. So essentially we're given the y-intercept, which is 1 point. But as we said earlier, we need 2 points. That's why we need to plot the 1 point first and then use the slope to find the second point. Okay. So I'm just going to draw and take marks here so we can draw our line properly. Okay, so we are given what? We are given y-intercept is 4. Okay, so since we are running a little bit out of space, I'm gonna change the slope to -2 over -3. And it's the exact same. The negatives cancel out, but I'm just gonna try to explain better with this. So let's say that the slope is 2/3. We can use, -2 over -3. It's gonna make the same line anyways. So when you have the slope, we see the y is actually on top. So let's start with the y first. You have to move the y first. So we're gonna go down to, you see -2 here to here, okay, to 2 here, and then we're gonna go to the left by 3, as you can see -3, and then we're gonna go here. So the actual point would be here, okay. So these 2 points, we can draw a line through that, and that will be our line 2/3 x plus 4. So you need to use this to use 1 point to find the other point with the slope. But you see, it's fairly hard to graph the y-intercept, okay, when it's a decimal. So if somebody gives you 5.657 as the y-intercept, I doubt you're going to really be able to graph that accurately on some graph paper, by hand. So of course we're not going to do that, right? We're not going to do that. Slope-intercept form is good method. It's fast for a lot of occasions, but sometimes we gotta use another form that just suits our needs better, right? The point slope form is probably the most universal form. It is most versatile. It can do anything because all you need is 2 points. You don't even need the slope. Okay, so in slope-intercept form, you need to be given the slope to use it. Okay, point slope form, you just need 2 points. Okay, and you can pick your points too. You can pick your points to be really nice points. Okay, you can pick your points to be 4, 5 instead of 4, 3.678. Okay, so what does this mean? So x and y are the general points. Okay, they're general variables. This the input, this output. Okay, so these are variables. Now let's go on to what these are. So this is the actual physical point that is on your graph. An actual point, x1 and y1. You can pick this. And then you need the slope. Okay, but with the slope, all you need is 2 points. You need 2 points to find the slope, and then you can pick 1 point to use it. Yeah. So I think the best way to find an equation of a line is using point slope form. The best way to graph the line would be slope intercept form. Okay. So are there any questions on this one? You'll get it when we do the example. Okay. I'm just gonna go over standard form real quick, and then we can do some examples. So standard form is you're taking a, which is a constant, times x plus by, which another constant is equal to c. So an example of this would, 3x plus 4y is equal to 5. And that would be standard form, but now you may ask, where are your 2 points? How do we get those 2 points? How are we going to do that? Okay. So one of the benefits of standard form or general form is finding the intercepts really fast. Okay, as you can see, we have all the y's consolidated, we have all the x consolidated. We can find the intercepts super fast. So essentially, you're given x intercept is going to be equal to c over a, and y intercept is going to be equal to a c over b, because when the x-intercept, you have x-intercept, you have to set the y equal to 0, and this just gets out of the way, right? And you can see very clearly what the x-intercept is. And since you can find the x-intercept and the y-intercept so easily, you can just use those to plot the points. But of course, the standard form has many flaws, so nobody really uses it. For example, x-intercept could be a really horrible number. For example, y-intercept and x-intercept could be really far apart, and could go out of the paper. You can graph line without ever seeing it touch the x-axis, because this line is so far up the y-axis. These intercepts are really far apart. So nobody really uses standard form to plot a graph. Nobody really uses point slope form to plot a graph. So I'd recommend slope intercept form to plot your graph. As you can see, you have the intercept, you have the slope. Very easy stuff. Okay, to plot, very efficient. Point slope form, all you need is 2 points. Very easy stuff to get the equation, and then you can convert it to slope intercept form. So let's say you have y minus 3 is equal to 2 times x minus 1. This is obviously point slope form. How do you convert it to slope intercept form? All you need to do is solve the equation. Okay, it's just this. All right, and we get a very clean slope intercept form. We can graph this very efficiently. Okay, are there any questions on that? If there are no questions, then I will continue on how to graph. I already talked about that. So again, I would recommend using the slope intercept form. So don't waste your time. If you use standard form to graph and you get really nice cooperative numbers, you can use definitely. But usually just convert it. Okay. All right. Now we can go on to some practice problems. So this one is just slope intercept form, very easy. Okay, so let's just check this real quick. Okay, yes, Zemo, I can go back to the point slope form. So if you need to take notes, point slope form is this one. So hurry up if you did not take notes of the point slope form. Okay, let's continue. So, well, you can't really graph it, but yeah, just give me the information. So you can, that's good. Just give me the information that you can get from the equation and graph it yourself. So now let's see how we can actually graph it. So do I have any volunteers? Any volunteers want to try to graph this? Okay, I'm going to call on somebody if you do not respond. Zemo, can you help? How about Zebo? Are you there? Okay, Devin, unmuted. Can you help, Devin? Okay, you're in library. Okay. Well, you should. Would you like to or not?
So the slope is 7/1, and the y-intercept is at 0, -3.
That's good. So you put the point here, right?
Yeah.
Okay, so now that you've had the y-intercept, what do you do now?
So the slope is 7. So for every increase in by 1 in the x value, the y value increases by 7. So your next point should be at 1, 4.
That's very good. So we can go up here by 7. We get -2, -1, 0, 1, 2, 3, 4. You have 1 here. Okay. As you can see, it's very slow, steep slope. Okay. So the higher the slope, okay, the higher the slope, the steeper the line. So if you have 100 slope, that's going to be extremely steep, extremely steep, basically vertical line. Okay.
But it will never reach vertical.
It will, yeah, that's true. It will never reach vertical. It'll be very close, but it'll never reach. Um, so, but if you have 1/2 slope, you can see that it's gonna get, flatter and flatter. It's gonna get really, really close. If you had 0.000001 slope, it's gonna be pretty close to
Yeah.
a flat
But
line.
the
Or
slope could get to 0. And at this point, if you're graphing a line with 0 slope, you only need to list the y-intercept.
yes, if you do, so like if you approach, the slope go down, you approach 0, there's no slope anymore. It's just there's no x, and there's just y is equal to -3. Then you just basically have a straight line here. If y is just equal to -3, there's no slope. So it approaches, and then it becomes flat. Or if 7 goes towards infinity, then you're basically gonna have um a pretty vertical line. Okay. So these types of approaching terminology, like for example, 7 approaches 0, that's calculus. But it's very good that you are thinking about these type of things at this level. Okay. Anyways, let's graph this next one. So this next one is in point slope form. So you need to convert it first to slope intercept form and then graph it. All right, so let's begin this one. So this one, let's see what you got here. So we obviously we're given the slope, right? We're given the slope, but we do need to find the y-intercept in order to graph it well. So actually there is a way you can graph it without converting. So let's convert it first and I'll tell you if let's say yeah, okay. So y plus 3 is equal to 3 over 2x minus 2. Y plus 3 is going to be equal to 3. Actually, let's just multiply everything by 2 first. Maybe it'll be easier on the calculation. 2y plus 6 is equal to 3x minus 6. Okay, 2y is equal to 3x minus 12. Y is equal to 3 over 2x minus 6. That should be what you have. Okay. And yes, the y-intercept would be equal to -6, and the slope is 3/2. You you can actually get this without without converting. If you remember the equation, it's y minus y1 is equal to m times x minus x1, right? So technically, 3 and -2 here are points. So essentially what we get from these is this should be 2, -3 is the point here. Okay, since we are subtracting, so it will turn into a -3 and then a +2. That's the point that we're given technically, and we have the slope, which means we can graph it like this, and we'll have this. Are there any questions on this? If there are no questions, then I will continue to the last one where you're using the standard form. Okay, so last method on how to do this. So you can choose which method that you like the most. Okay, so after this lesson, you can think which one you think is the most relevant to the problem. Of course, critical thinking skills. If this one you need to graph efficiently, maybe you want to use a slope intercept form. This one you're given 2 points. You're going to use point slope form, right? So make sure you use the right one. Okay, so let's go over this one. All right, so for this one, you need to use your knowledge on x and y intercepts. So you can graph 6x minus 2y is equal to 12 using their intercepts. So let's find the x-intercept. All you need to do is to put y is equal to 0, 6x is equal to 12, therefore x is equal to 2. You can also use the shortcut that I told you about. C over a is equal to 12 over 6. Y-intercept, okay, we're going to use that trick here. This is 12 over -2 is equal to -6. Once we have those two intercepts, all you got to do, go on the graph 1, 2, 3, 4, 5, 6. Here's our y-intercept. Here's our x-intercept. Bam, that's our line. Okay, so it's that fast. If you get good numbers, only if you get good numbers though. Okay. So that is all for today's class, I think, on basically graphing lines. So now you know how to graph a line. Lines are very important later when you are, doing higher levels of math or any applied math, because many things have linear patterns, spending money. You can use linear regression in AP statistics or any type of statistics. Linear regression is quite important. Just linear relationships are quite useful in the business world, finance too. So anything that you can find a relationship with. Or linear relationships are also just the first thing. Okay. But anyways, that is all for today. So I'll see you guys next time, which is April 7th. So don't come.
All right. Huh.
Okay, see you guys.